I think we'll get started now. We've got a pretty solid crew and we want to respect everyone's time, so appreciate those who have taken the time to join us today. My name is Zach with ATS, in case you haven't been on any of our previous ATS university sessions over the last few months. We've been seeing a lot of different requests for different topics along the way. And Will and I actually did one, I think it was one of our first ones. Will Kublis, who's with A.O. Smith and is going to be presenting today. We did one of our first ATS universities on some hot water options, especially the newer products. But coming out of that, we had a lot of questions on really the ins and outs of sizing. And there is a pro size software, which Will's going to run through today. It's available online from A.O. Smith. But we also want to talk about some of the quote unquote old school ways and some of the nice resources that are available from A.O. Smith. So really, without any further ado, I am going to pass it over to Will so that we can get through what's probably a lot of content. And just as a reminder for all those on the call, we have everyone muted upon entry, but you can raise your hand if you wish to ask a question live. I'll unmute anyone along the way. But you can also use the Q&A fields and the chat fields. I'm sure everyone's pretty well aware of all these fields at this point with all the different training seminars that are going on, but good to reiterate. So thanks for joining us, and Will, I'll pass it over to you.
Thanks, Zach. You guys can hear me okay? Just testing, make sure that you can hear me.
Yeah, you're sounding good.
Perfect. Okay. All right. I'm sure like a whole bunch of you folks there are working from home like I am. So I am coming to you live from my home. So what I wanted to do here today is just talk about some of the methodology that we offer here at A.O. Smith for sizing commercial water heaters, and also a couple of applications that are more difficult to find on our ProSize tool, and talk about tankless water heaters, which we made it a lot easier too because we've added tankless water heaters to our sizing application program. So my function in the company, I'm one of the area reps for A.O. Smith, and I spend an awful lot of time working on commercial applications and helping with selections and so forth. So I'm going to share with you some of our methods here. So
I guess just I'll jump in there really quick because I know we do have some people from out west, BC, Alberta, and I think Manitoba and Saskatchewan as well. For any questions along the way, you can reach out to me. I cover all of Canada. Will is covering Ontario, and we can definitely introduce you if you just reach out at zach@atspec.com to the local A.O. Smith rep out there as well.
Great, thank you. Selecting the proper size equipment. We have all of these different methods here. So we introduced ProSize back several years ago. It's our online sizing tool. I'll show you how to get to that. And the applications, we're going to run through a couple of the most common applications on it. We have, if anybody still has our orange catalog, we also have that orange catalog now in a USB format. But there is sizing documents that A.O. Smith developed years ago that are on our website, and I'll just show you quickly how to get to those. Of course, there's the ASHRAE sizing guide that's available at the ASHRAE store. You can purchase those guides, and I'm sure a number of you have those already. Our ProSize is based off of ASHRAE, and so are our sizing documents that we have. The other way to size a heater is if it's an older building and you're just replacing like for like, every water heater has a label on the side of the boiler, the water heater, with what storage and what recovery data is there. So sometimes replacing like for like is a pretty good method, you know, providing your client has never had issues with the system in the past. We're going to run through the Hunter's curve for tankless water heaters. Sizing tankless is actually very easy, and so I'll show you that. And ultimately, we do find a number of engineers like to reach out to ATS and AO Smith for assistance. So we know our equipment and we know what they're capable of doing, and we're more than happy to help you choose the right equipment for your specific project. So our website, you really want to use our hotwatercanada.ca as much as possible. The reason for that is that our products that we have here in Canada are made for Canada. For example, our electric water heaters, we have on our spec sheet here in Canada 600 volt data, but in the US they don't have 600 volt available. So our spec sheets are a little bit different. And we do have some products that, well, it has to be approved for Canada. So everything that's on the Canada site is approved for our market. And on our website, you'll see the tab engineering or engineers. That's where you're going to find our ProSize program. You would click on engineers and you'll see our ProSize program there. And that ProSize program will look like this. And there's all your different applications that we offer in ProSize. And I'm going to run through an apartment and also a restaurant application. I'm sure we'll have time for that. So I'll get to that. There is also some documents that AO Smith developed. I'm going to go back 20 years now ago, but I find them very useful. They're on hotwater.com. They're on our US site under resources, and then product literature, you'll see sizing diagrams, and ATS is going to post those in a blog so you can have quick access to those after this is over. But the one highlighted there, industrial plant, it has just some like kind of explaining what to do. So like industrial showers, for example, there might be 30 showers in an industry or in the shower room. So after the shift, all those showers will be running, and it tells you in there, assume that all the showers are going to run for 20 minutes, because generally if employees had to wait more than 20 minutes to get in the shower, they'll probably just go home. So it kind of gives you that little bit of information that's, and I believe that was all done on university studies and so forth and gathered up and put into a nice document. So I really like them. They're very short read and get right to the point. And in industrial showers, they tell you to put most of that into storage, and you know, you might have 8 hours to recover the system. So, and then we have for apartments, we have hair salons, concrete, several churches, schools, all that is available in that sizing section there. So just what we basically do when we help with the size, we need to determine the type of building. So like an apartment building, you have, they are categorized into 3 different types of buildings, and you'll see that on ProSize. There's a low peak, medium peak, and high peak demand type building. And the low peak would be a building that was mainly seniors. So maybe a seniors building would be a 3-hour recovery. Then if you have a mix of people that, like working people, students, and seniors, they would be a medium peak. And then if it was all students, it would be a high peak. So we need to determine that. It is sometimes a good idea to draw out a timeline of use of your water, like for example, maybe a Zamboni fill at a hockey arena, and the Zamboni needs to fill. You know, they want to put water in the Zamboni as quick as they can, but that Zamboni might be back 40 minutes later to refill because they have another rink to do. So we need to rebuild that tank within less than 40 minutes. So it's drawing the timeline will definitely help figure out what size equipment you need. you have to determine whether it's intermittent use or continuous use. So if it's intermittent, it becomes more of a storage, you know, you want to have enough in the bank kind of thing to get you through maybe that intermittent period, and then you can choose smaller boilers. However, a continuous operation is something where the water turns on at, say, 8 in the morning and doesn't shut off until 5 o'clock. That's going to be a different size system, and I'm just going to talk about that in a second. You have to determine dump loads. And those are fast, high volume draws that generally most water heaters can't provide on a minute by minute basis. So you want to have that in all that water in storage. So we'll talk a little bit more about that in a second. And then of course, you're going to obviously calculate both your storage and recovery rate. And the nice thing about ProSize is it does that for you. So a good example, though, of some dump draws, commercial sinks. So if you're ever looking on the ASHRAE sizing principles, they say in a commercial kitchen, you have a single pot, a double pot, a triple pot. And commercial sizing, you would put 30 gallons for a single, 60 for a double, and 90 for a triple. And that would generally be in storage. So in the case of you know, a restaurant with a triple pot sink, I would want to have at least a 90-gallon water heater for that sink. Same with commercial laundry. There is on those sizing documents I provided, or that are available on our website there, they'll tell you that put 3 gallons of hot water per pound of laundry and 3/4 of a gallon of hot water per pound of laundry. So they want to fill that laundry machine fast, and they will fill quickly. So they want to have that in storage just so that your equipment doesn't have to be like overly huge. Industrial showers, we talked about that they would normally be in storage, that 20 minutes of use. And then emergency showers, that's a commonly asked question. So I'm going to run through an application of that. Zamboni fills are also a high dump load, so they usually are always in storage. And any industrial process where they're filling a tank for whatever, making cosmetics or whatever. So, and then of course, any fast fill requirements. So where they want to put a whole lot of water and transfer it very quickly, you really want to put that in storage. So continuous draws, a little bit different. So a continuous draw would be like a good example. I was just in a facility where they wash eggs all day long. It's going down conveyors, and that spray of tepid water is washing the eggs continuously for hours on end. That would be how we would size that. Continuous draws are the first 15 minutes of the use would be in storage. And then of course the recovery rate would have to equal the flow rate of your hot water. So first 15 minutes of your water in storage, and then if you're using 100 gallons an hour, you need a water heater that's going to produce 100 gallons an hour. Keep in mind that a tank has a draw efficiency. So because you have a 100-gallon water heater, you don't have 100 gallons of hot water. The bottom 30% of the tank is being mixed with the cold incoming water. So you have 70 usable gallons of hot water before the temperature drops more than 30 degrees from the set point. So now, on the emergency shower side of things, according to the occupational health and safety requirements, it is available online, that they ask for 20 gallons per minute for 15 minutes is the requirement. And they tell you that the shower temperature should be anywhere from 68 degrees Fahrenheit to 100 degrees Fahrenheit, depending on WMIS recommendations for that facility. So it will be different for all different facilities, because one place may be dealing with toluenes or something, where somebody could be contaminated with something, and WMIS will recommend what is the appropriate temperature for that particular type of contamination that somebody got. So they may require 70-degree Fahrenheit water for that, whereas another facility may require 80-degree water, or some 100. So I'm going to run through some of those examples there and show you how my methodology is on how I determine what size heater. So I also wanted to say that emergency showers I would consider mainly a dump draw. So most of it is going to be in storage. So here's an example. The emergency shower output temperature is going to be 70 degrees Fahrenheit. So as we said, 20 gallons per minute for 15 minutes equals 300 gallons of water that needs to flush at 70-degree Fahrenheit. So I use our mixing formula to determine how much of it's going to be hot. So M minus C over H minus C. M is your mix temperature, C is your cold, H is your hot. So I've determined that 30% of my 300 gallons is going to be hot water. So I need 90 gallons of 140-degree Fahrenheit water from my tank. So one of our light duty electric water heaters, our DEN 120, has 84 usable gallons of hot water. As I mentioned, the 70% draw efficiency. So it's 120 gallons times 70% equals 84 gallons. So I have 84 in storage. So I'm 6 gallons short of meeting that requirement. So I need 6 gallons more in 15 minutes. So I would have a water heater that actually has 24, that would produce 24 gallons per hour recovery rate to give me 6 gallons in that 15 minutes. So 24 gallons divided by 4.1 gallons per kilowatt equals 6 kilowatt water heater. So that is our light duty DEN 120, 6 kilowatt, available in 208, 240 volt, or 475. If you wanted to go gas tankless, that works out that you would need 4.5 gallons per minute flow rate out of a tankless heater. And one tankless heater can produce 3.8 gallons per minute at 140 degrees. So you would really need 2 tankless water heaters to do that job. A little bit different now when you go to 80 degrees, when you do your mixing formula. Now 40% of your water is hot, or 120 gallons. I have to switch up now to a different model, our DRE series, whereas I step back for a second, the DEN 120 is only available up to 12 kilowatts is the maximum. So now you would switch to our DRE 120 model, still has 84 usable gallons of hot water. So now therefore, I'm short. I'm looking at, I need 120 gallons, right? So I'm 36 gallons short out of the storage. So I need to make up 36 gallons in 15 minutes. So that's 144 gallons per hour. So my recovery rate, I now move up to a DRE 120 with 36 kilowatts. So quite a jump to satisfy that shower. And now I have a flow rate of 6 gallons per minute. So again, 2 tankless gas water heaters would also do that job. Now I'm going to go to the higher temperature. Somebody wants the emergency showers at 100 degrees Fahrenheit. That means 60% of my water is coming from the hot water tank. So the DRE, they're capable, or you can purchase them with up to 54 kilowatts. The DSC model is available with higher kilowatt input. So the DSC has still the 84 usable gallons of hot water. So therefore the heating elements need to make up 96 gallons in 15 minutes or 384 gallons per hour recovery rate. That would be 93 kilowatts of power. So that's a lot to ask on a facility. So at this point, you may want to go to our build to order electric water heaters, where we build our DREs up to, well, we make them from 140 gallons up to 3,000 gallon size capacities. So we can build one heater and reduce the kilowatts by putting more of that water in storage. We put all 180 gallons in storage and just have the kilowatts recover. Usually we don't recommend anything longer than 4 hours to recover.
Very well. Just
Sure.
a quick question came in regards to that 4.1 gallons per kilowatt. Can you talk about where that comes from?
Yes. So it is on our spec sheet for our electric water heaters. It's below the chart, but 1 kilowatt will heat 4.1 gallons of water per hour at 100-degree rise. That's a pretty standard rule of thumb in the industry. So that number would change if of course we're going to store water at a higher or lower temperature than 140, but we assume 40-degree water going in, and you're storing it at 140, so that's a 100-degree rise. So 1 kilowatt will heat 4.1 gallons of water per hour. So on the emergency showers, a good question came up. What happens when there's more than one shower? So basically, I have found that in a facility, they would have an emergency shower where it's convenient for the employees that are at risk. So I tend not to see them all clustered together. You might see one at this corner of the building, another one at that corner, and another one at the other corner. So for most of those applications, I would just size it per shower and use one water heater per shower. Unless there's several of them, then at that point you can either twin 2 of these heaters together or go with any of our custom heaters. So again, if you need to consult with us on that, by all means, ATS and us are happy to help make sure you get the right size for your application. So moving off of emergency showers, and going to talk about tankless here. So we use what they call the ASHRAE modified Hunter's method for sizing tankless water heaters. So we have to determine the building type, obviously apartments, schools, restaurants. With tankless, you have to count up all of the hot water fixtures. So if it's an apartment building, we need to know the kitchen sinks, all of the dishwashers, all of the lavs, showers, everything, all added up. And then we assign a fixture unit to each one of these hot water fixtures. That I'll show you the chart in a second where we get that information. Then we total up all our fixture units. So if we have a 100-unit apartment building, we have 100 kitchen sinks, 100 lavs, we have 100 dishwashers. We would just total all of that up. And then we're going to use a graph to determine our hot water flow rate that the Hunter's curve provides us. And then once we determine that flow rate, we would just use this simple formula, B2 output equals your gallons per minute times 500 times your delta T, which is we always assume 40-degree in and storing your water or our set point at 140. You can change that if you want. If you only want your tankless water heater set at 120, you can change that. But your B2 input will change a bit. So the B2 output, I put that in there because some of our products are different efficiencies. So our tankless water heaters that we have, our commercial units are 95% efficient. So whatever B2 output I get, I would divide by 0.95 to get my B2 input. We also have some tankless units that are 82% efficient. So we would divide the B2 output by 82. So on the, and I don't know everybody read this.
Quick question coming in
Sure.
again from the chat, and I think we have this every time we've done a lunch and learn, back in years past when we're in person, and we've had it a couple of times already for this, but the modified Hunter curve or the ProSize software based on the ASHRAE sizing guides, do those account for low flow fixtures? And because we get a lot of comments regarding oversizing.
We show you what the fixture units are in this sizing guide, and I think it's just an average fixture unit. You can see there are some different numbers in here, which I think are pretty fair. So the chart I have up on there right now, I just copied to the right apartments because I wanted to show you all the different applications on the left side of the screen that we have: hospitals, restaurants, factories, clubs, and whatever, but apartments are very common. So I just enlarged on the right side of the apartment section. So the fixture units that we're showing there, there's your private labs at 0.75 fixture units, which is basically a flow rate. So private showers, 1.5 gallons per minute. If that's of hot water, right? So that would be a mix. So that 1.5 is like 2.2 gallons per minute of shower flow rate, which is pretty standard shower now. And then of course, Energy Star is a 1.5 gallon per minute shower head. And then 65% of the 1.5 gallons would be hot. So really they are maybe a little bit on the oversized for Energy Star type applications. So
these fixture units, you said they're coming from ASHRAE. Are they the same as the OBC fixture units?
I'm not sure.
Okay. We'll double check that and get back to you, Sujin.
Yeah. So anyhow, if I'm sizing this apartment, I'm going to use these numbers here. I have, kind of documents that were provided by me or not by me, by our company, and I just like to use the tools that were given to me. So I use this unless there was a more updated fixture unit sheet, then maybe I would consider that, but this is what we have at this time. So anyhow, I would total up all my fixture units for that building based on this information, and then we use the ASHRAE modified Hunter's curve. This is also in the it's in the ASHRAE sizing guide as well. So if let's just say I totaled up 100 fixture units, I would then find my apartment housing curve C, curve C in there, which is the second curve up, and it is somewhat of a guess there. I'm going to say it's probably about 27 gallons per minute would be the flow rate that I would be looking at as a maximum for that that building. So it's not 100 gallons per minute. We're not going to obviously assume that all of the fixtures are going to run at the same time. This curve takes that into account, that there is going to be a kind of a logical flow rate, expected average number of faucets being used at a peak time. So once I have my gallons per minute So I'm at 27 gallons per minute. I would go back to my formula here and punch in my 27 gallons per minute times 500 times my delta T, and that's going to give me my BTU output that I need for that particular building. So and in that case, let's say I'm 27 gallons times 500 times 100. I'm at 1.3 million BTU output. If I was going to use our tankless heaters, I would be looking at here 1.3500 divided by 200,000 BTUs each. I would need 7 units in that building to do that example. So that may discourage some people, but we do build rack systems as well, so that we have up to 6 tankless water heaters and 1 rack. So the contractor carries in 1 station and hooks up 1 hot water line, 1 cold water line, 1 gas line, and he could accomplish that building. So that's basically our manual method for sizing tankless. And of course, everybody loves using software, and it is a whole lot easier when you have a sizing program here.
Just a quick point.
Can you see that screen now?
Yeah.
The site pro size?
Yeah.
Back?
Can you hear? Yeah, we can see it.
Are you able to see that, Zach? Anyhow, I have my, this is the ProSize program here. And of course, you can see all our different applications that we have here. And we also have a payback calculator on there. And it's a great tool when you're, say, renovating an older building and wanting to put in high efficient equipment. You can show the client that there's how much fuel savings they would expect from this equipment. But so I'm going to pick on the apartment buildings here. And so in an apartment building, it's a fairly straightforward system where you basically start at the top and just check what you would like to do. So we have water heaters only with no external storage. We can do water heaters with external storage if required, because some storage tanks can be a little less expensive than heaters. So you can economize, maybe put 1 water heater in with a couple of storage tanks. Here's our commercial tankless as well. And just a word of caution, the values are more in flow rate than in fixtures. And boilers with external storage. So of course we build hot water circulators that you can use with storage, and great advantage of that is you can mix and match. You can build whatever size BTU you need with our boilers and select your own storage tanks. So in a lot of time, we can build you, big custom heavy duty tanks, or we do have our 120 gallon tanks that tend to fit through doorways and so forth. So you put your fuel type in, natural gas, and in our example, of course, all our product in Canada would be indoors. These little buttons here are for the low NOx, and ultra low NOx are for the state of Massachusetts and California and so forth. We don't have that requirement here in Canada. If you want ASME certified equipment, you would click on that button. Our products for that are available in Canada, we click on our Canadian product. In this case, I did select water heaters. So I'm going to let the computer program pick out the number of heaters for me. So I'm not going to specify. You can say, hey, I want 2 heaters in this on this. If you know you want to make sure you have redundancy, it'll pick 2 for you. Your altitude, because we do have some people from BC and so forth. You can alter your altitude levels there. Can change your water temperatures. We automatically just assume you would want to store the water at 140. Bacteria doesn't grow at that temperature, so that's a good storage temperature to have. Then down here, your load profile. So we did pick an apartment building, and I mentioned medium peak, low peak, high peak. If you're not sure, there is a little button here. Just put your cursor over top of it, and it will help you determine which is a low peak, medium peak, and a high peak demand for your type of building. Right now, the medium peak is 2 hours. You can customize it if you want. Now here, this allows you to enter in your shower head flow rate, as somebody had mentioned before. So if you know what that is, I believe the lead shower heads are 1.2 gallons a minute now. Energy Star is 1.5, and most shower heads that are out there today are 2.5 gallons per minute. And I believe there was some changes recently to our Canadian offering that I think shower heads are now 2.2 gallons a minute. So it allows you to adjust that.
2.2 is kind of the standard these days, and hopefully my audio is a little bit better now. I've reconnected on the phone. But 2.2 is kind of standard. 1.5 would be as low as I'm kind of comfortable pushing it, but we do have some lower flow. One thing I'll say for the, say for the class, if you are going lead and you need to go lower than 1.5, make sure you're not just putting a lower flow shower head on a valve designed for a 1.5 flow rate. You can get a lot of kind of searching in the valve, and you can cause a lot of complications. So if you are going with an ultra low flow shower head, make sure that the valve matches. And then a couple of questions have come up along the way here, Will, and I'll just jump in and kind of ask a couple of these that have come up. First, if you're having a research system, how can you work that into the tankless unit? And then the second questions come around the application types. So maybe we can go over some of the application types a little bit more detail after this example.
Sure, yes. So going back to the tankless there and answer this question on the research system, we have a tankless model that has a built-in research pump into it. If you want, it's ideal because it's you can program it to be on a timer. So 2 time periods per day, you can have it set so that at 7 a.m. to 9 a.m. you could have it circling, and then shut off and then turn back on again at say 5 until 9 or so. Just know that water circulation is bad for water pipes, right? So having it controlled, or at least on a timer, even on off, is a really good idea, not only for your pipes, but also for the hot water equipment as well. And with tankless, we always aim to circulate between 2 and 4 gallons per minute. Anything less than 2 gallons a minute can produce air bubbles, and anything over 4 gallons a minute also can produce turbulence and erosion of the core heat exchangers, as well as your pipes as well. So that's our target in there. And I had one particular person, it was a smaller building, and I thought this was genius. They put motion sensors in areas of their building where they needed circulation. So where they had like a men's washroom, and most of the time nobody was in that washroom, but when somebody walked in, the motion sensor turned on a pump. which I thought was great. And then, of course, those sensors, they're set up so that if you leave the room, 2 minutes later, it senses no motion, so it would shut the circ pump off. And I thought that was a great idea. The tankless unit we have, as I said, there is one model. So if you were, say, banking 4 tankless heaters together, one of them would have the circ pump built into it, and you don't need to purchase any additional circ pump, I guess, depending on your length of run. So, but anyhow, hopefully I answered that question. So in our building example here, we have 2.5 gallon per minute shower head. So now it's asking us for the number of bathrooms, not units. So units with 1 bathroom. So I have, let's just say 100 units in my apartment building, and it allows you to adjust the number of persons per unit. So if it's a 1 bathroom unit, our pro size automatically just assumed that there's on average 1.5 persons per unit. So you can change that around if you wish. Also, it has, if you have laundry in each facility, you can just click on that and it will automatically apply the laundry for each unit. But if you have say a laundry room in the facility, it will allow you to go in here and put in, say, 4 machines. And normally I look at the laundry machines, like the coin operated laundry machines, 20 to 25 pounds, because laundry is usually based in pounds. So I would put in, my laundry machines are 25 pounds. So I got 4 machines, 25 pounds in there. And then down in here will allow you to say, okay, I want to be sure, I'm not short. You could have some people in this building go and take off the shower heads and go put on, different flow rates afterwards. And I'm always concerned about that, making our sizing incorrect because the shower heads got replaced with some other drench type or even moved completely. But so you can go in and add in so some different extra gallons per hour in your system here, either just by percent oversize or additional, like, I don't know, maybe they have a car wash in the underground parking of this building. You might want to put that in here. But I can say in this, want to make sure that I'm 50% or I want 70% oversized. Nothing wrong with that. This is going to pick out basically your bare minimum requirements for this building here.
And I guess on that point, that extra demand area is great if you have like a eye wash in your mop sink area. Depending on the chemicals that are used for cleaning these days, we do sometimes have that requirement for an eye wash in the janitor sink area. So you could add that demand first, do the calculation like Will walked through earlier, and then add in that amount of demand there, and you could add it in. And Will, just before you jump into the actual product selection, another question came up, and I think it's really important, so it'd be good to go back to the sizing guide there.
Yes.
Again, can you go over how you choose the peak demand period again and show the different options?
And you're talking here my pro size.
Yeah.
Application? Yes.
The medium peak.
Oh, I see. Okay, sure.
That.
Yes. Okay, good. So as I was saying that, like because we're in the apartment building application, we or even ASHRAE categorizes apartment buildings into 3 categories. And the three categories here, there is this little button in here that if I click on that more information, it helps explain the categories here a little bit. So low peak demand, I generally use that for, like, if it was more of a seniors type of residence. I'm not saying nursing home. I'm just saying that it's a facility where a high percentage of the people are retired people, and generally people that are elderly don't tend to shower as often and use as much hot water in a timely fashion. So whereas younger people, they get up at, say, 6 in the morning, they got to be out the door at 7. So you have a building, let's just say, has 200 people in it. Those 200 people, there's a very high percentage of 200 people are all going to head for the showers all between, say, 6 and 7 a.m. Whereas senior people tend to maybe head to the showers between 8 and 11, like 8 or, in a 3-hour period. So 8, 9, 10 o'clock, you'll have all those people spreading it out over a 3-hour period. Whereas the college students will all, same number of people in the building, but their water system's going to be different because you now have all those students heading to the shower within an hour. So that's going to make a big difference in the recovery and selection of your equipment. And it's very easy to take ProSize and just run some different examples without you having to reload your data all the time, just by a click of the button here. And then I could go and choose different equipment. I'll give you an example here. So let's just say I got a low peak demand and I have a 100-unit bathroom with the coin operated laundry in here. It's going to pick out this picked out one BTH 500. So it's a 120 gallon water heater with 500,000 BTU input into that building. But if I go back and change this to a high peak demand, now I have a whole bunch of people all running to the showers, the same number of people. Look at it, it's picked out one of our, this is our new extra large 1 million BTU water heater that we're just releasing, or double 2 BTH 500s. Same building, different occupants. So different.
That's a big boy unit, that BTHS 1000. And I guess that kind of ties to another good question that came in. And just a heads up, we are also only about 10 minutes left. I had a feeling we might be running long, but we'll try to keep this quick and appreciate if anyone needs to jump off. We totally understand. The question came in on how is it, and I think it's probably in those design guides, but is there a ratio or a rule of thumb for kind of increasing storage versus reducing your recovery, or vice versa?
Yes. And the one thing, if you go on the ASHRAE sizing guide, so they have a graph of storage versus recovery. A.O. Smith sizing guide picks a point on that graph. So it doesn't necessarily mean that's the only option. Generally, as a rule, as you increase storage, you can decrease your recovery. And that graph that's in the ASHRAE sizing guide does offer that. So it gives you liters per storage, liters per occupant, and also a recovery rate of liters per occupant. And then, of course, you have to use that, times it by the number of occupants, and then find the graph, and it will show you all sorts of different storage and recovery details in there. But that's in the ASHRAE guide, and that's a document that you have to buy from ASHRAE. it's wouldn't be fair for us to be able to copy it and share it. I think there'd be some copyright things there, but you would go to the ASHRAE store and get that. And they have that graph for pretty much all of the different applications for apartments, for same again, I don't think it's so much for restaurants, but mostly apartments, hotels, motels, that sort of thing.
And I guess that does tie into a couple of the other questions. If you can go back to, I guess, the application type selection. A number of questions came in on whether or not we're looking to add more applications and some specifics like where would a retail application fit in here?
So, as I say, yeah, the selection guide, like it's missing a few things. Like I say, the emergency showers are not there, and it's not the be all to end all. So that's why I also wanted to share those sizing documents with everyone. That would be on that blog you're talking about, Zach.
Okay, perfect.
But there are in all of those documents that are in that blog, there is a section on hot water consumption for each fixture. So it does talk about like a mop sink. You know, we put 10 gallons of water per hour per mop sink. And I would normally put, you know, the 10 gallons into storage because that's a dump load, right? The custodian is going to fill a mop sink with hot water. He wants to do it quickly, get on with it. So that would be a dump load. But there are documents.
So you could kind of use those design guides and then put the information into like the user supplied demand application would be your go-to for that? Sure,
that would work, yes. Yeah, and you would have to total it all up. And that's the one thing about the ProSize, and I hadn't gotten to that part yet, but it gives you that nice report at the end, nice PDF report. So it's nice to have a trail of, and whenever I do a sizing document, I always save it and keep it for, you know, future reference or so forth. And you know, as an engineer, I'm sure you would like to put that in your file of how you determined what size water heater, you know, and just it keeps all your load data, which I would like to show you guys that.
Yeah, I'll let you kind of get to that, and I'll just say to the crowd as you're going through this again. Thanks. You know, I recognize that people are probably going to have to jump off in the next couple of minutes, and I appreciate you spending this time with us. I recognize that, you know, this is really over your lunch hour, so I appreciate you spending the time. There's a lot of good questions, and if you do have any questions after the fact, Will and I are both happy to kind of walk through an individual application that you might want to discuss, and we can show you how that might fit into this ProSize software. So if you do have any further questions after and need to jump off, just shoot me an email, zach@atspec.com, and I'll get that organized for a follow-up. And we will also have our follow-up coming out on Friday with all those documents and a copy of the presentation.
Right, yes. If I could do, if anybody could just sit through one more, I'm going to jump off the apartment for a second here. And I just wanted to show the restaurant application because it's a very common one. And there's a little button in here that I found very useful for the dishwashers. And there are several hundreds of different brands and models of dishwashers, and we have it here. So when you're doing a restaurant, typically a water heater is what they're looking for. We do tankless. Myself in a commercial restaurant, I'm a little concerned about the number of cycles that could happen on a tankless heater. If you do the ASHRAE Hunter's curve, you'll notice that tankless water heaters, they all start at 4 tankless heaters for a restaurant. And that's just because they're filling pot sinks, they got a dishwasher, a hand sprayer, labs going, and the number one complaint out of a restaurant is they just have such low flow with only 2 heaters or so. So ours always start at 4. And I think that's pretty common in the industry. So usually I would probably try to put a tankless with a storage tank so that they could have some high draw, short draws from it. But in the sizing for the restaurant application, it does talk about peak demand. That's your, the restaurant's busy from 11 a.m. to 2 p.m. And if you put in the meals served, it will kind of downplay the equipment a little bit. But if I just leave it at 1 hour, that means whatever water I use in that 1 hour, my system has to rebuild it and have it ready for the next hour. So I prefer to use that myself. And then the meals served, it doesn't really matter. A dishwasher can only run so many dishes through an hour. And same with the sprayers. But, there's your data. You fill in all your sinks and whatever down there, mop sinks. But when it comes to the dishwasher, they're asking you, we need to know the model of the dishwasher. This is huge because some restaurants are, small under the counter type of dishwasher. They may only be 20 gallons per hour usage, but generally like an Applebee's, Boston Pizza, I find them to be about a 70 gallon per hour dishwasher. But if you're not sure of the flow rate, because we're asking you the capacity here, this is in US gallons per hour. But if you look at your view equipment list over here, A.O. Smith has directed you to, it's a website where all of the different manufacturer dishwashers are here. So Hobart, very popular brand of dishwasher. You can go on click on this, this button here, and it takes you to pretty much most, I find it, I'm going to say 80% of the time I find the dishwasher information here, and it tells you whether it's a chemical rinse type of a dishwasher. So a Hobart LT-1 is a 20 by 20 rack, and it will use 70.3 gallons per hour of hot water using a chemical rinse method there. So I wanted to make sure you saw that part of our restaurant application. So other than that, like I say, if you go and clients got a triple pot sink and maybe a single pot sink, they have 2 lavs in the men's room and 2 in the ladies, and maybe 2 kitchen hand washing sinks. So let's just say they got 6 lavs. They might have to mop the floor during business time. They got a bar sink. They have a hand operated pre-rinse sprayer. Usually that's the sprayer the dishwasher guy would use to pre-rinse off any of the dishes. We have a dishwasher that's 70 gallons per hour at 140 degrees. And then I would click on my select, and it's going to pick out an appropriate heater. So it's common. BTH 250 is a very common water heater for a restaurant. I like that option. So let's say I click on it, and it's going to direct you to a little bit more information about that heater. And then the option now for your selection report. So I can load in my data here, hit view report, and it's going to provide me with a nice PDF report that I can share with my client. This is what your heater's going to look like. It gives you the information about the heater. It tells you your peak demand is 305 gallons per hour. Type of application was a restaurant. All your information on the load data is on the second page here, showing you, which I find important because, I quite often see an engineer will ask us for some advice and not necessarily say we have a dishwasher picked out yet at this time. So here I did a selection based on 70 US gallons per hour, but maybe it's only a 50 gallon per hour dishwasher, or maybe the client chose something else that's 150 gallons per hour type of dishwasher. So this is very important information to keep.
And if they had gone with the meals served per day approach, is that really for the whole day, or like breakfast to dinner, or is that, you know, meals in an hour? What information should they be asking the owner group for?
Yes, so that is the meals served per day. So I like kind of thinking of an apartment building, the same sort of thing. Like if there's 100 occupants in an apartment building, there's only going to be 100 potential showers in a day, right? And spread out either over a 1 hour, 2 hour, or 3 hour period. So in a restaurant, if they're only serving 100 meals per day, and you put in the peak period of say 4 hours, it's basically going to take those 100 meals and spread it out over the 4 hour period, right? And a lot of the time, you know, you're going to size it based on capacity, right? So the number of seats in the restaurant, and like I don't think I would feel comfortable, you know, saying that our restaurant's only going to be 25% full, right? We don't know that, especially in a new type of facility. You're kind of hoping that's going to be 100% full all the time. So if I just stick to the 1 hour peak demand for a restaurant application, I can't go wrong, because that's going to assume my dishwasher is at full capacity. I'm using my hand sprayer, which those documents that I was telling you about restaurants, and which you're going to share there, they tell you that a pre-rinse hand sprayer assume 45 gallons per hour. And that's not something that A.O. Smith made up. That's based off of ASHRAE sizing principles. And you know, it's nice to know that after the fact, I could go and take a bucket and measure, you know, how much water one of those hand sprayers uses in an hour, I guess. We could go and time it, but we don't have that luxury when we're designing a system. We have to assume that it's going to be used like 45 gallons per hour. Maybe it's only used 20 because the restaurant's not at full capacity, but we don't know that, right? So I stick to these values, and you know, the odd time I get to go walk through a restaurant and talk to the owners of it, and they can tell me that the dishwasher is only used for maybe 15 minutes every hour, because we're, you know, that's the type of business they have. They never fill this sink. They hardly ever use that sink, and fine, okay, then I'll size it based off of that. But being that it's a new facility, I'm sure everybody, the owners, are hoping that it's going to be a busy, profitable type of business. So we got to size our equipment accordingly.
Yeah, and I think that's a good point to tie into, again, that question regarding, you know, the ASHRAE fixture units and the OBC fixture units, which we'll certainly investigate the correlation there between the two and get back to everyone with their feedback. But with ASHRAE and really with the modified Hunter's curve, that was done by kind of doing what you're talking about there, of talking to the individual locations, but on a massive scale. It was all across America back in like the 70s or 80s, which obviously fixture units have changed, but they've not done a large sample to understand how demand has changed. So for now, this is still our best guess until, if ASHRAE or whoever decides to go do another Hunter's curve type sample. Until then, our fixture units that we have are the fixture units that we have, and we've got to design with them.
Yes.
So any other kind of final points you want to bring up here, Will?
The only thing I said, like, I think the sizing training could you really could spend a whole day going over all the different applications. So I just wanted to show you some of the quick tools and some of the methodology that we use. Those documents, we refer to those. And between that, we usually solve our question of what size equipment we need. And I do appreciate the ASHRAE, the curve, the graphs that they offer for apartments. I'm not saying that A.O. Smith, this is the only size. It's not. As I said, there is a graph, and we basically pick something off of it with the amount of storage and recovery that makes sense, for a facility. Our main goal in sizing, and this was something that was told to me years ago, we want to size a system so that it will not drop more than 30 degrees from our set point. So if I have a tank set at 140, it should not drop below 110 ever. If it is, my system's too small. And also, we do not want to have more than 6 cycles per hour as a rule. That's our ultimate end goal in sizing equipment. So to make a system that's going to last but that's really, as I said, application wise, there's a lot of different things in here. I've never used the military barracks one yet, or the prison. I've never been asked that, but pretty much most of the other ones I've used, gyms and so forth. And if there's one last takeaway from everybody, make sure you put a thermal expansion tank on your hot water system. Very, very important for these heaters for any hot water system to last. So that's very important for that. And there's sizing programs. Amtrol has it. Watts has one as well. So anyhow,
I think that's a great kind of closing point there, Will. And of course, if you need help sizing your expansion tank, or if you want help with the ProSize software, you can certainly email myself, zach@atspec.com, Mo or Steven or Melanie, whoever your ATS MD person is, or of course our spec team, which I'm sure if you guys have been using the spec team email spec service over the last couple of weeks, you might have noticed that we're switching over to a more service desk type platform using a ticket field. Work with us as we, I'm sure, work through a couple of kinks as we switch over to hopefully what we will find is improved customer service. The goal is to improve transparency and give you guys an idea of where your projects are in the queue of our building. And of course, you can send in your hot water sizing request to us there. We'll run through this ProSize software and send you the selection reports, and we'll work with Will. Thank you, Will, for spending the time. And of course, if there's any other questions that come in from the chat, we'll either address them to you after the fact, or you can reach out to us and we'll go over it on email, or we can set up a kind of firm-specific version of this if you have specific questions for your firm. So yeah, we'll talk to everyone soon. Thank you, Will, for joining us, and thank you everyone for attending.
Thanks for supporting A.O. Smith. We appreciate it, and like I say, we're there to help. And I know it's not always these applications are straightforward, and even we need time sometimes to just sort of think through these things. That's why I say I always try to draw out a timeline and totally understand the application. So sometimes the communication might be back and forth a couple of times. I know it gets a bit annoying, but hey, it's better to be safe than sorry. So anyhow, appreciate everyone listening, and thank you very much for supporting A.O. Smith.
Have a good day, everyone. Bye for now.
Take care, Zach.